Today I am presenting you the video number 2 for lesson number 4, structure of atom. In the previous video we have studied about the subatomic particles, their discovery, their location, their mass and their charge. Now today we will start with the different atomic models. As you all know that Dalton's atomic theory has suggested that atom was indivisible, which cannot be broken down into simple particles. But then what has happened? There were discovery of different subatomic particles, protons, electrons, neutrons, and thus it was proved that atom is divisible. Next step was, it was necessary to know that how the electrons and protons are arranged in the atom. For explaining this, many scientists proposed various models. The main efforts were of Sir J.J. Thomson, Rutherford and Bohr. J.J. Thomson was the first scientist to propose the model for the structure of atom. What he has shown, he has compared the model of atom with that of a watermelon. He has told that the positive charge is spread all over the sphere like a red part. The red part which is there in the watermelon, he compared that part to be the positive part, that is proton. While the electrons are the seeds, the black seeds which are present in watermelon, he compared the electrons to those seeds. His model can also be compared with that of a Christmas pudding. The electrons are embedded in the sphere of positive charge, like the dry fruits which are there in the pudding. So one thing was clear, that atom is a sphere, and he gave the position of electrons and protons. This was there in the J.J. Thomson's model. He compared that atom consists of positive charge all over and the electrons are embedded in it. But this model failed at various aspects because it could not explain the stability of atom, that how positive charge is holding the negative charge, how they both are being contained in a sphere, and it also has no statement for the position of nucleus. The nucleus is present or not, he couldn't tell us that. Therefore, this model subsided and it failed. Next model is of Rutherford model. In 1911, Rutherford had performed an experiment for studying the scattering of alpha particles by a thin metal foil. You know, alpha particles are positively charged particles and which are emitted from a radioactive substances like radium or polonium. But Rutherford has taken radium as a source for the generation of alpha particles. And what he did in this experiment, he produced a narrow beam of alpha particles from this radioactive source, that is radium, and directed this to a thin sheet. You can see a gold sheet is there, a gold foil is there where these alpha particles are striking, and at the end you can see there is a movable circular screen which is coated with zinc sulfide. Okay, so why the screen is there? It is there to help the direction in which the alpha particles are moving. A flash of light was produced on the screen when alpha particles were striking the screen. Whenever they were striking the screen, a flash of light was produced and it can be easily detected through this screen of zinc sulfide. So what he observed in his experiment, he observed that most of the alpha particles passed through the foil without any deflection from their path. You can see they are moving straight. Most of the alpha particles, they are going straight without any deflection. A few of them deflected at some angles, you can say 90 degree or more than that, after passing through them. You can see here some of them are showing the deflection. And one more thing he observed, that very few turned back to their original path. You can see in the picture, it's hardly one of the alpha particle which is turning back to its original path. So what he observation inferred, what information we get from this observation were, since most of the alpha particles were passed through the foil without any deflection, which shows that atom is not at all a solid, but it is extraordinary hollow and consists of lot of empty space in it. Second observation he gave, a few alpha particles were deflected from their original path through some angles, which suggested that there must be something heavy positively charged at the center of the atom which is repelling, and that's why alpha particles are showing deflection from their original path, because something positive is there in the atom also, and alpha particles are also positive in nature. That was the second inference. Thirdly, he observed that a very few alpha particles turned back to their original path without undergoing any deflection. This suggested that nucleus is very dense and rigid, which could not require the alpha particles. A very few alpha particles are deflected. We conclude that the size of nucleus is very small. Therefore, the very less number of alpha particles were getting deflected. This was there in Rutherford's model of alpha particles. These were the conclusion that atom is in the center and it has a nucleus which is surrounded by the nucleus, this electron, and nucleus is positively charged. Thirdly, the size of nucleus is very small as compared to the size of the atom. These all conclusions were drawn from the Rutherford model. It also failed on certain aspects. It failed because Rutherford model was not able to explain the stability of atoms. Still, the stability was not at all explained through this model. And he also didn't mention anything about the arrangement, how the arrangements are located, where is their position in the atom. So this model also failed. Next came Niels Bohr in the year 1913 in order to explain the stability of atom and to overcome the objections of Rutherford model. What he has told that atom consists of small, heavy, positively charged nucleus at the center. Why heavy positively charged? Because in the nucleus we have only protons and neutrons. So the net charge is a positive one. And he also told that electrons revolve around the nucleus in a circular path called orbits. So electrons are revolving around in a circular path only in different orbits. Orbits can also be known as shells. And he also did the labeling of shells as K, L, M, N. Means the shell which is closest to the nucleus, shell number 1, is regarded as K shell, then L shell, M and N shell. This was there. Then he has also told that as long as electron remains in a particular orbit, it neither emits nor absorbs energy. Thus, in a particular orbit, energy of revolving electrons remains constant or stationary. It is having a stable energy. Hence, each fixed orbit is associated with a fixed energy. Every particular orbit is having a fixed amount of energy. This was explained by Niels Bohr, which has actually explained the stability of atom. Since the electrons cannot lose energy and fall into the nucleus, so they are stable. Then one more thing he has explained, that energy associated with each energy shell increases as we go away from the nucleus. Means K shell is having the lowest level of energy level as compared to L, then M and N will be having the highest amount of energy. Okay. Then when electron is present in lowest energy level, the electron is said to be ground or in normal state. In ground or normal state, the potential energy of electron will be minimum and therefore it is most stable. The emission or absorption of energy in the form of radiation can only occur when electron jumps from the stationary orbit to another orbit. The energy gained or lose is equal to the difference of energy of the two energy level. If it is moving from its ground state, then its energy level is changing, and the energy level can be calculated by subtracting the two energy levels. When the electron gains energy, then what happens? It jumps from a lower energy level to a higher energy level, and then the atom is said to be in excited state. And excited state is unstable. Excited electrons again jump back to a lower energy level by losing the energy. So these were the postulates of Bohr atomic model. All the three models have been completed in this video. Thank you.